All right, so the rest of the lecture for 6-1. What rate of interest, yearly interest, is required to turn a $100 investment into $1,000 in 5 years? So, again, the very first thing you should be doing, I say should, that really means you should do this, is always write down your formula. All right, so what do I know? I have my principal of 100. This would be the amount after time passes, and this is literally the time. So I'm just going to plug that all in the right spot. So 1,000 equals 100 times 1 plus r to the 5th power. All right, so there's this 100 right here. We can divide that out. And 1,000 over 100 is what, 10? So 10 equals 1 plus r to the 5th power. Now the opposite of the 5th power would be the 5th root, or the 1/5 power, however you want to do it. I'll write this out. The 5th root of 10 is the 5th root of 1 plus r to the 5th. And of course the 5's cancel. Now, in a calculator, you're going to have to raise that to the 1/5. So 10 to the 1/5 is 1 plus r. And before I even go push buttons in a calculator, let's just move this 1 over. 10 to the 1/5 minus 1 is my rate of return. It's easy peasy, kids. It ain't hard. Well, if you still don't know how to fix a square root, this is impossible. I don't know how. I'm not even sure how you breathe. Anyways, there's 10 to the 5th. Take away the 1. That's a pretty hefty rate of interest. 0.5849. Which would be 58.49%. All right, same question, but monthly rate. So the time here is 5 years still, but in months, that's 60 months, right? So it's going to be the same exact setup, except we're just going to replace the 5 with how many months there are in 5 years, which is 60. Still going to divide by 100. And the opposite of the 60th power is going to be the 60th root, which is what number times itself 60 times creates a 10, and I don't know it. Sixties cancel. And in a calculator, you're going to raise 10 to the 1/60th power. And just like before, we're going to subtract that 1 before we go push buttons. Because the goal here is isolation of the variable, because that's the answer. If you want to actually know what it is, you go push buttons. So 10 to the 1/60th power, and then take away a 1, is 0.0391. Or 0. Shift twice, Benjamin. Or 3.91% per month. Per month. All right. Moving forward, you recently purchased a 2025 Razor 1000 Turbo for $27,995. The Razor will decrease in value at a rate of 13% per year. Write a model for the future value of your Razor. So this is a decay problem. It's decreasing. So the formula is basically the same, except instead of 1 plus, it's just 1 minus. So the model here, the model only cares about getting a formula that you can plug things into, would be that the amount after time passes is that principal of $27,995 times 1 minus 13% is a decimal, 0.13. Don't be that kid who can't figure that out to some time. And again, do not stop here. Do not stop at 1 minus 0.13 and leave that as your answer. I will take points off. I will. It just makes no sense to stop there. You can't figure out what 100 minus 13 is? 1 minus 0.13 is 0.87. Good Lord, you could go push buttons on a calculator, kids, couldn't you? You could. So do it. All right, determine the value of the Razor in 2029. So you bought the thing in 2025. Now it's 2029. 4 years have passed. We're going to find the amount in 4. Notice I'm replacing t with 4 because she is a 4. And I just got to push buttons on this and see what this is. That's all I have to do. It's probably not worth as much as this model is suggesting. This UTVs, your side-by-sides, they're a horrible investment. $16,038.27. Notice how we rounding in money. $16,038.27. All right, using technology, aka a graph, when will the value of the razor be? $55,200. Now, this is the goal to get to. This is the amount after time passes. So it's going to go here, right there. So 5,200 is equal to 27,995 times 87 hundredths to the time. And we're going to y1, y2 it. We're going to play with our window. It's not a hard problem. So 5,200, 27,995. Learn how to use your calculator because, well, for one, you don't know the algebra to do this yet. Now, what I'm going to do is zoom 6 like I always do. I'm going to play with the window though. I have to look up to see 5,200 because this window only goes to 10. So I am going to do a Y max adjustment. I'm going to set it to be 6,000. And I know I'm probably going to have to look more than 10 years in the future, but we'll see. You know, we'll see. All right. So window Y max 6,000. I don't expect to see anything 10 years in the future, but I could be wrong. There's the $6,000 or the $5,200. The curve is going to be up here somewhere because remember it starts at 27,000. It's way up here, and it has not decreased down to 5,200 yet. So let's look 20 years in the future by changing our X max to 20 and see if that does the job. If not, we'll do 30. I kind of thought 20 would do it. Ah, there it is. So I also set my X max to be 20, as in 20 years into the future. And let's see how long it takes. So second trace, 5 for intersect, enter, enter, enter. And it took just a touch over 12 years. It was 12.09 years. I'm looking at my X value here, 12.087. So the time is roughly 12.09 years. If you bought this thing in 2025, in 2037, it's only worth $5,200. You know the worst thing about side-by-sides is I've got one. First year the transmission went out, $5,000. Drove it a year, now the engine's out. That's another $5 grand. That's the worst thing about them. All right, a certain investment grows by 23% every month and a half. If you invest $100, write a model for your future investment. Okay, so this is kind of interesting. Your default formula is that the amount after time passes, for growth anyways, and this is growing, is the principal times 1 plus r to the t. Now, that's like per month or per year. All right, it's quantities of time frames of 1. This is every 1.5 months. When you see an every statement like this with something other than 1 month or yearly or whatever, you're going to have to make this the time over what I like to call the time period. So when I write a model for this one, this is still my principal. This is r, and she's 0.23. The only thing I really have to change is the exponent. So the principal here is $100. Think about what 1 plus 0.23 is real quick. 1.23. And I'm going to put t over 1.5. Because this happens every month and a half. The every is a direct indicator to a slash and a divisor symbol. Now, what will your investment be worth in 4.5 years? We don't mix units in math. We do not mix units in math. So I need to take this years, and I need to convert it into months. You know, that's 4.5 times 12, which is 4854. 54 months. So that's going to be my time. So the amount in 54 months, because this thing is about months now, is 100 times 1.23 to the 54 over 1.5. And every bit of that can just be pushed in a calculator. There's nothing wrong with going to a calculator. But you're going to have to learn how to write too. I mean, you've got to be writing. Or you can be like every other kid that's argued with me. Losers. Wow. Of course, that's a month, every month and a half it grows by 23%. But wow, $172,418.56. 172,418. I think I said 52 cents. Nope, 56 cents. It's a chunk of money. At one point in time, we would be worth $10 million. $10 million. So the amount becomes 10 million. It's just equal to our little formula here. And it says, you know, use a graph. So use a graph, kids. Now obviously you're going to have to play with your windows some. So 10 million in Y1. That's a million, right? Need another zero. Of course, we don't have a T button. Don't be that kid who asks where the T button is. There actually is one, but it's for parametric equations, which you've never heard of in your life. Anyways, I'm going to do a zoom 6 just to get my window back to default. It's useless, again, because we only go 10 years in the future, and we only go up $10 in this case. And I need to go up $10 million. So I'm going to set my Y max here. Whenever my little calculator's done doing this little thing, it'll be 11 million. And let's see, 4.5 years was 54 months, and we weren't quite there yet, were we? So let's just go out to 80 months. That's 80 months. And I bet it happens. You're going to see the growth happen. It's going to take off at some point in time real soon. Oh, it didn't happen in 80 months. Bummer. Alright, so let's go out to 100 months. Probably should have started there in the first place. That's 100 months. There we go. Second trace. Second trace 5 for intersect. Enter, enter, enter. 83.42 months. What is that in years, you know? I'm pretty sure that there are 12 months in a year. So let's take that 83.42 divided by 12. It's 6.95 years, right? 6.95. Let's see what that translates into months. So minus 6. That'd be 95 hundredths of a year. Let's multiply that by 12. 6 years, 11 months. And in math, we say that the average month has 30 days. So let's take away the 11 because that's in months. And let's convert that 42 hundredths of a month into days by multiplying by 30. Roughly 13 days. You're worth 10 million bucks. And you'd be an absolute fool to move your money from that. All right, here's a good decay problem. Your wealthy great-grandmother invested $12 million in a trust fund when you were born. Problem is, it's been poorly managed, has decreased, notice that keyword, decreased in value by roughly 18% per year. You gain access to this account on your 18th birthday. Will you be rich? First off, let's do our model. Now, this is decay, okay? So the amount after time passes is the principal times 1 minus the rate of decay to the time. All right? Now, what do I know? I know that the principal is a whopping $12 million. 18% is 0.18. So 1 minus 0.18, and then to some t. And again, we don't stop there. You know, do not be that kid. I cannot stand that kid. I'm tired of seeing that kid. So go away, kid. 1 minus 0.18, bless you if you got to push buttons in a calculator, is 82 hundredths. There's your model. Now the question is you get access to this account on your 18th birthday, or you're going to be rich. So let's find the amount that it's worth in 18 years by simply letting the time be 18. So we got 12 million times 0.82 rooftops to the 18th power. You're going to have some cash, but you ain't rich. You can buy you a house, not even that good of one anymore. $337,155. And how many pennies? 76 pennies. Grandma should have done better, but you still got left quite a chunk of money. I mean, that is life-changing money. It'd be life-changing money for me. It would be, but I wouldn't be rich. I wouldn't be rich. Big difference between us working people and rich people. Anyways, there's the rest of your lesson. Hope you enjoyed.